All right, take a look at some multiple choice. If f of x is 5x to the 4/3, then f prime of 8 is... So our strategy here is, of course, to find the derivative and then plug 8 in. So the derivative using the power rule, f prime of x is 5 times 4/3 times x to the 1/3. Then really we can just put the 8 in. When I put the 8 in, the cube root, or the third root of 8, is 2 times 4/3 times 5 should give me 8 times 5 should get me 40/3. And taking a look here, our limit as x goes to infinity from pre-calculus. We should remember that we look for the degrees, and I've got a degree 2, and I've got a degree 2. So if the degrees match, we just look at the coefficient of the highest degree term. So it should be 5/4. All right, and the third one, we've got a little bit of a simplification problem. If f of x is 3x squared plus x over 3x squared minus x, then the derivative is... Now, we could do a few things in this one. The first thing I would probably do before I derive is actually factor out that x. So if I factor out that x, I'm going to get 3x plus 1 over 3x minus 1. Now I can't really cross anything else out besides that x, but that's just going to clean up or make less simplifying in the end. So we do our low d high minus our high d low over our low squared, our quotient rule. So low times the derivative of the high minus high times derivative of the low over low squared. Now that's not an option right here yet, so I've got to definitely do some simplifying. If I distribute, I get 9x minus 3 minus 9x minus 3. So then these are going to go away. I'm going to be left with that negative 6. And there it is. All right, if the function f is continuous for all real numbers, and if f of x equals x squared minus 7x plus 12 when x over x minus 4, when x doesn't equal 4, then when it does equal 4, so basically we're just trying to figure out a piecewise function. It's going to be continuous everywhere on this part of the function, everywhere but 4. So then at 4, what would the function have to be to fill that hole in this case? So really it's like an algebra 2 pre-calc problem. If we just factor the top, we're going to get rid of that x minus 4, which is going to give us our hole. So it's going to look like y equals x minus 3 everywhere except for at 4 where the hole is. So then if I plug 4 in, 3 is 1. And we've actually seen this one on one of our worksheets. The limit of 4 times sine x cosine x minus sine x over x squared as x goes to 0. Now, of course, we can't just put the 0 in. So we've got to do something else. So we want to really know our properties as x goes to 0. And one of the special ones is, if I factor a sine out of that, I get cosine minus 1 over x squared. And so our two, basically this one has both of our special ones in it. If I break this up into the sine of x over x times the cosine of x minus 1 over x, 4 times that, the limit as x goes to 0, what happens is this one ends up being 1, this one ends up being 0, so it's 4 times 1 times 0. So the answer is 0, but you can definitely see how undefined might get hit. The other one's really, I don't know that you could make those mistakes. So sometimes on these problems, it's a matter of narrowing it down, remembering properties. Definitely going to get more practice.